Imagine a financial application that is transferring funds between two accounts where a customer's account got debited but the credit to other account fails. You are left with an incomplete transaction and data inconsistencies can be a nightmare. This is where Spring's transaction management makes it easy. Generally, a transaction performs multiple operations or sub-transaction to it. So a transaction is a single atomic unit of work, it's all or nothing. Either all operations succeed or none do. This is also called atomicity. Such transactions also guarantee consistency, isolation and durability. Spring uses the Platform Transaction Manager to manage transactions, but the real magic is with add transactional. Transactional annotation at class level makes all public methods in that class transactional by default. Here take an example, transfer service class annotated with transactional. The public method transfer funds and methods invoked from it comes under one unit of transaction. Except do something else method, since it has transactional attribute with propagation as requires new, this will be eligible as separate and new transaction every time it's called. The context or the metadata of each transaction is maintained with a dedicated thread local, so each dedicated thread local are well aware of its transaction state and execution. If any method call execution fails or throws exception, the entire transaction is bound to rollback, that is execution happened so far get rolled back. At this point, you might assuming that thread locals are doing this execution or rollback mechanism, but that is not true actually. Thread locals are only there to maintain the transaction context. The actual execution or rollback is done by the Spring's AOP mechanism. When a method annotated with a transactional, Spring's AOP interceptor intercepts the call. The interceptor checks if a transaction is already active or not. If not, it starts a new transaction using the configured Platform Transaction Manager. Then the business logic within the transactional method is executed. If the method completes successfully, the transaction is committed by the interceptor. Otherwise, with exception, the transaction will be rolled back. Finally, Spring also provides mechanisms for handling exceptions within transactions. Following are the various transactional attributes with different purposes, and to control the creation and execution of transactions, I recommend to explore these attributes quickly from Spring Transaction Management before going to any Java interviews. Cheers and thanks for watching. We'll see you in the next one.